Okay, so 3, 7 is even and odd functions. And even and odd are algebraic definitions. They're not, does it look even or odd? It's depends on the algebra. And the reason that we classify things as even or odd is so that we know what their qualities are. Now, this year in Algebra 2, you just need to be able to classify it as even or odd. That's it. Next year, you'll classify things as even and odd, and there'll be theorems that are true if something's even and theorems that are true if something's odd. But this year, you just have to be able to classify. All right, so first things first, even and odd is not, we're not talking about even numbers or odd numbers. That's not what this refers to at all. The other thing it does not refer to is an even degree or an odd degree. Has nothing to do with the degree of the function. So I want to just throw that out there so you don't get your brain into the wrong area. Okay, so Roman numeral 1, first thing we're going to do is visually categorize graphs. Visually categorize graphs. Okay, so what I want you to do is in this remaining space, I want you to draw, we're going to have number 1 and then we're going to have number 2. I want you to draw 2 pairs of axes. They can be pretty kind of smallish. Okay, so the first category we have is even graphs. Even graphs look symmetrical across the y-axis. So left to right, they look symmetrical. So an example of an even graph would be a parabola with its vertex parked on the origin. If we draw a dashed line down the y-axis, you can tell that the left and the right look the same. Another way to determine is it an even graph is if you can fold it in half and the graph maps onto itself. So if I were to fold it in half, it would all line up. That's an even graph. Even graphs can also be camel type graphs. Again, as long as if you draw a dotted line down the y-axis, it folds in half, it is an even graph. So that's how you look at a graph and determine if it's even. Okay, so the other category of graph is an odd graph. And an odd graph is what we call symmetrical across the origin. Symmetrical across the origin. So our origin, of course, is 0, 0. So that's our origin. And a very common example of an odd graph is an S-shaped graph going upwards. Okay, so a trick to figuring out if a graph is odd is if you flip it upside down and it looks the same. So if I take this graph that I just drew and I turn my paper over, it looks exactly the same. If it looks exactly the same, then it has symmetry across the origin and it is an odd graph. So more elaborate versions of odd graphs might have bumps in them. much your test is the same. If you can flip the graph upside down and it looks identical, then it is odd. Now, there are some graphs that aren't even or odd. There are some graphs that just aren't. In which case, if you were asked, is it even or odd, you would say neither, because it doesn't meet either one of those qualities. So even and odd and neither are pretty much the three categories. Okay, so we're going to practice. On your paper, I want you to do A, B, C, and D. And I want you to decide, you can use a pencil if you want so you can fix it or cross it off if it's wrong. But I want you to decide if the graph is even, odd, or neither. So here's graph A. So on your paper, write down, is it even, odd, or neither? Okay, here's B. Even, odd, or neither. Okay, here's C. Even, odd, or neither. Here's D. Even, odd, or neither. All right, let's see how I did. So graph A, if I were to fold it in half down the y-axis, it would map onto itself perfectly. So A is an even graph. Okay, B, if I were to fold the paper in half, does not map on itself. But if I flip it upside down, it looks exactly the same. So B is an odd graph. Okay, so for C, now this is a little bit tricky. Remember that an even graph is only symmetrical through the y-axis, not anything else. So if I fold this along the y-axis here, I have a short piece and a big piece. So it isn't symmetrical across the y-axis. It's symmetrical across x equals -1, but that's not the definition. It has to be just the y-axis. So not even. If I flip it upside down, it points downward, so not odd. So this one would actually be a neither graph. It is not even nor odd. Okay, then let's look at D. If I fold this graph along the y-axis, it's going to map onto itself. So D is even. All right, so that's how you identify even and odd graphs visually. All right, so Roman numeral 2, this is a more exact way. We're going to do algebraic categorizing. Algebraic categorizing. Okay, so there's two rules you need to know to categorize. If your function is even, then f of -x equals f of x. That's the formula. If your function is odd, f of -x is equal to -1 times the original function. All right, so let's do an example. Let's say you've got f of x equals 2x to the 4th plus 3, and we want to know, is it even, odd, or neither? Okay, so most people do the even test first. And if that fails, they try the odd test. So the even test says if I replace every x with a -x, I get what I started with. That's what that means. So we find f of -x, and again, this is your even test. So in this, I replace x with a -x, so I need parentheses, and then I simplify it. Well, any negative number to an even power is positive, so this becomes 2x to the 4th plus 3. Okay, and then what you have to ask yourself is that equal to the original function f of x equals 2x to the 4th plus 3? Well, yes, we replaced x with negative x, and when we simplified, it looks exactly the same as the original function. So the answer is yes, it is an even function. Okay, let's do example 2. F of x equals negative 2x cubed minus x. And we're going to start with the even test. So for the even test, we need to find f of negative x. So you're going to replace all the x's with negative x's. So negative 2 times negative x cubed minus a negative x. And we simplify. Negative x cubed, you always do exponents first, is a negative x cubed. So now I have a negative 2 times a negative 1 times x cubed. So do your power first. So we got an x cubed with a negative parked out front. And then simplify. Multiply. Negative 2 times negative 1 is positive 2x cubed. And a negative times a negative is a positive. So the question is that equal to the original function, which was negative 2x cubed minus x? No, it does not match. So our function is not even. Okay, so once you do the even test, it's easier then to do the odd test. So in the odd test, I'm going to write the rule here. Does f of negative x equal negative 1 times f of x? So the nice thing is if you just did the even test, we already found this, f of negative x. It's right there. So we already have that. You don't have to do it again. So what we want to know is what is negative 1 times the function? So I'm going to take a negative 1, put the original function in parentheses, negative 2x cubed minus x, and simplify. You get positive 2x cubed plus x. Now the question is that equal to f of negative x, which we already found was 2x cubed plus x? Well, yeah, they're the same function. So in this case, yes, we have a winner. It is an odd function. And that's how you algebraically check to see if something's even and odd. Most people do even first because that way you can use your f of negative x for the odd test, and you only have to do then the right-hand side. All right, questions?